The early 16th century, the world's understanding of the universe was about to be turned upside down. For centuries, people believed that Earth was the center of everything, with the sun, stars, and planets all revolving around us. But in 1543, a Polish astronomer named Nicolaus Copernicus introduced a revolutionary idea that would forever change our view of the cosmos. His heliocentric theory placed the sun, not the Earth, at the center of the universe. This bold proposal challenged deeply held beliefs and set the stage for a new era in science. For Copernicus, the dominant model of the universe was the geocentric system, developed by ancient Greek thinkers like Ptolemy. According to this view, Earth sat motionless at the center, while the sun, moon, and planets moved in complex paths around it. This idea was widely accepted by scholars and the church alike, shaping how people understood their place in the cosmos. The geocentric model seemed to fit everyday observations like the sun rising and setting, but it struggled to explain the true motions of the planets. Nicolaus Copernicus was born in 1473 in Torun, Poland. He grew up in a time of great change with new ideas spreading across Europe. Copernicus was well educated, studying mathematics, astronomy, and medicine at several universities. His curiosity about the heavens led him to question the old models and seek better explanations for the motions of the planets. Copernicus's background in both science and the humanities gave him a unique perspective, allowing him to approach problems in creative ways. As Copernicus studied the skies, he noticed that the geocentric model didn't always match what astronomers observed. The planets sometimes appeared to move backward in the sky, a puzzling phenomenon known as retrograde motion. To explain this, the old model relied on complicated systems of circles within circles, called epicycles. Copernicus began to wonder if there might be a simpler, more accurate way to describe the universe. His doubts set him on a path toward a groundbreaking discovery. Copernicus developed a daring new idea. What if the sun, not the Earth, was at the center of the universe? In his heliocentric model, Earth and the other planets revolved around the sun in circular orbits. This arrangement elegantly explained the strange motions of the planets and did away with many of the complications of the old system. Copernicus's theory was a radical departure from tradition, but it offered a simpler and more accurate picture of the cosmos. After years of careful observation and calculation, Copernicus finally published his ideas in 1543, in a book titled On the Revolutions of the Heavenly Spheres. The book laid out his heliocentric model in detail, complete with mathematical proofs and diagrams. Copernicus waited until late in his life to share his work, knowing it would be controversial. His book marked a turning point in the history of science, opening the door to new ways of thinking about the universe. The heliocentric model, the sun sits at the center, with Earth and the other planets orbiting around it. The moon, however, still orbits Earth. This model explained why planets sometimes appear to move backward in the sky and why their brightness changes over time. By placing the sun at the center, Copernicus's system made the motions of the planets much easier to understand and predict. It was a simpler, more elegant solution to the mysteries of the heaven. When Copernicus's book was first published, it attracted both interest and skepticism. Many scholars were intrigued by the new model, but others found it hard to accept. The idea that Earth was not the center of the universe challenged long-held beliefs and religious teachings. Some critics dismissed the heliocentric theory as unrealistic, while others saw it as a useful mathematical tool but not a true description of reality. The debate over Copernicus's ideas had only just begun. The Catholic Church, which held great influence over intellectual life in Europe, was cautious in its response to Copernicus's theory. At first, the heliocentric model was seen as a mathematical convenience rather than a literal truth. But as more scientists began to support Copernicus's ideas, the Church grew concerned. The notion that Earth was not at the center of creation raised deep theological questions and threatened established authority. Many astronomers and philosophers resisted Copernicus's heliocentric theory. They argued that if Earth were moving, people should feel it and objects should behave differently. The lack of observable evidence for Earth's motion made the new model hard to accept. For decades, the geocentric model remained popular and Copernicus's ideas spread slowly. But a few bold thinkers began to see the potential of the heliocentric system. In the late 16th century, Danish astronomer Tycho Brahe made detailed observations of the planets and stars. Although he did not fully accept the heliocentric model, his precise data would later prove crucial. Brahe's work provided a wealth of information that future astronomers could use to test and refine Copernicus's ideas. His commitment to careful measurement helped lay the groundwork for a new scientific revolution. Building on Brahe's observations, German astronomer Johannes Kepler developed 3 laws of planetary motion. Kepler showed that planets move in elliptical, not circular, orbits around the sun. His work provided strong evidence for the heliocentric model and helped explain the true paths of the planets. Kepler's laws brought new precision to astronomy and confirmed many of Copernicus's insights. In the early 17th century, Italian scientist Galileo Galilei used a telescope to observe the heavens. He discovered moons orbiting Jupiter, phases of Venus, and countless stars invisible to the naked eye. Galileo's observations provided powerful support for the heliocentric theory, showing that not everything revolved around Earth. His discoveries challenged old beliefs and inspired a new generation of scientists. Galileo's support for the heliocentric theory brought him into conflict with powerful authorities, including the Catholic Church. He was tried by the Inquisition and forced to recant his views. Despite this, Galileo's work spread across Europe, fueling debate and encouraging others to question traditional ideas. The struggle between science and authority became a defining feature of the era. In the late 17th century, English scientist Isaac Newton brought together the work of Copernicus, Kepler, and Galileo. Newton's laws of motion and universal gravitation explained why planets move as they do, providing a solid foundation for the heliocentric model. His theories unified the heavens and the Earth under the same set of physical laws, marking the true dawn of modern science. Acceptance of the heliocentric theory changed how people saw themselves and their place in the universe. No longer at the center, humanity became just one part of a vast, dynamic cosmos. This shift in perspective encouraged new ways of thinking, not only in science but also in philosophy, art, and religion. The Copernican Revolution was about more than astronomy, it was about changing minds. Nicolaus Copernicus's bold idea paved the way for centuries of scientific discovery. His willingness to question accepted wisdom inspired countless others to explore, experiment, and seek the truth. Today, Copernicus is remembered as a pioneer who dared to look beyond tradition and imagine a new universe. His legacy lives on in every scientist who asks, what if things are different than they seem? Heliocentric theory was a key spark for the scientific revolution, a period of rapid change and discovery in Europe. Scientists began to rely more on observation, experimentation, and mathematics to understand the world. The old reliance on authority and tradition gave way to a new spirit of inquiry. The scientific revolution transformed not just astronomy, but physics, biology, and every branch of science. Modern astronomy owes much to Copernicus's heliocentric model. Today, we know that the Sun is just one of billions of stars in the universe, and our solar system is part of a vast galaxy. The tools and techniques developed since Copernicus's time have allowed us to explore distant planets, stars, and galaxies. The spirit of curiosity and discovery he inspired continues to drive science forward. Copernicus relied on careful observation, mathematics, and logic to develop his theory. He studied ancient texts, made his own measurements, and used geometry to model the motions of the planets. His approach combined respect for tradition with a willingness to innovate. By blending old knowledge with new ideas, Copernicus showed how science can move forward. Mathematics played a crucial role in Copernicus's work. By using geometry and arithmetic, he was able to predict the positions of the planets more accurately than ever before. His mathematical models provided a foundation for future astronomers who would refine and expand upon his ideas. The partnership between math and astronomy remains essential to this day. Copernicus's theory was built on careful observation of the night sky. He watched the movements of the planets and stars, recording their positions over many years. These observations allowed him to spot patterns and inconsistencies in the old models. By trusting what he saw, Copernicus was able to challenge centuries of accepted wisdom and open the door to new discoveries. Doubt played a key role in Copernicus's journey. He questioned the explanations that didn't fit the evidence and refused to accept answers that didn't make sense. This willingness to doubt and ask questions is at the heart of scientific progress. Copernicus's example reminds us that challenging old ideas is often the first step toward new understanding. Heliocentric theory had practical effects beyond astronomy. As sailors and explorers ventured farther from home, understanding the true motions of the planets and stars became increasingly important for navigation. Copernicus's model helped improve maps and navigation techniques, making long-distance travel safer and more accurate. Over time, Copernicus's ideas became part of the curriculum in schools and universities. Students learned about the sun-centered system and the evidence supporting it. The heliocentric model became a symbol of the power of reason and evidence in education, inspiring generations of learners to think critically and question assumptions. The Copernican Revolution influenced not only science but also art. Artists began to depict the universe in new ways, inspired by the idea of a sun-centered system. Paintings, sculptures, and literature reflected the changing understanding of humanity's place in the cosmos. The heliocentric theory sparked creativity and imagination across many fields. Philosophers grappled with the implications of the heliocentric theory. If Earth was not the center of the universe, what did that mean for humanity's importance? The new model encouraged people to see themselves as part of a larger, interconnected cosmos. This shift in perspective influenced philosophy, ethics, and even politics, encouraging a more humble and open-minded approach to knowledge. Heliocentric theory sparked intense debate within religious communities. Some saw it as a threat to traditional teachings, while others found ways to reconcile the new model with their faith. Over time, many religious thinkers came to accept the sun-centered system, seeing it as a deeper reflection of the order and beauty of creation. Though Copernicus's era was dominated by male scholars, women also contributed to the advancement of astronomy. Over the centuries, women like Caroline Herschel and Maria Mitchell made important discoveries and helped expand our understanding of the universe. The spirit of curiosity and inquiry that Copernicus embodied inspired people of all backgrounds to explore the cosmos. Heliocentric theory encouraged the development of new technologies, from improved telescopes to more accurate clocks. These tools allowed astronomers to make better observations and test new ideas. The relationship between theory and technology became a driving force in scientific progress, leading to ever greater discoveries. Copernicus's theory spread across Europe through books, letters, and conversations among scholars. The printing press made it easier than ever to share new ideas, and debates about the structure of the universe became common in universities and salons. The rapid spread of knowledge helped accelerate the pace of scientific change. The Copernican Revolution encouraged people to question authority and think for themselves. Scientists, philosophers, and ordinary people began to rely more on evidence and reason than on tradition or dogma. This spirit of independent inquiry became a hallmark of the modern world, shaping everything from politics to science. Scientific progress often depends on collaboration. Copernicus's ideas were tested, refined, and expanded by other astronomers, mathematicians, and thinkers. The exchange of ideas across borders and disciplines helped create a vibrant scientific community. Today, collaboration remains essential to discovery and innovation. Copernicus's theory gained acceptance because it was supported by evidence. Careful observation, measurement, and prediction allowed scientists to test and confirm new ideas. The emphasis on evidence over authority became a defining feature of modern science, ensuring that knowledge would continue to grow and improve. The story of the heliocentric theory reminds us that science is always evolving. New discoveries can challenge old ideas, and our understanding of the universe continues to grow. The search for knowledge is never finished, and each generation builds on the work of those who came before. Today, humanity explores the universe with powerful telescopes, satellites, and space probes. Our understanding of the cosmos has grown far beyond what Copernicus could have imagined. Yet, the spirit of curiosity and the drive to understand our place in the universe remain as strong as ever. The legacy of the heliocentric theory lives on in every mission to the stars. Curiosity drove Copernicus to question the old models and seek new answers. This same curiosity fuels scientific discovery today. By asking questions and exploring the unknown, we continue to expand the boundaries of knowledge. Copernicus's example reminds us that curiosity is one of humanity's greatest strengths. The heliocentric theory changed not just science but society as a whole. It encouraged people to think critically, value evidence, and embrace new ideas. The spirit of the Copernican Revolution continues to shape our world, reminding us that progress depends on open minds and a willingness to learn. Copernicus's heliocentric theory shows how a single idea can change the world. By daring to think differently, Copernicus inspired generations of scientists, artists, and thinkers. His story is a testament to the power of ideas and the importance of challenging the status quo. As we look to the future, the lessons of the heliocentric theory remain relevant. Science thrives on curiosity, evidence, and the courage to question. The journey that began with Copernicus continues today as we explore new frontiers and seek to understand our place in the universe. Nicolaus Copernicus lived to see his book published, but he died shortly after its release in 1543. He may never have known the full impact of his ideas, but his work set in motion a revolution that would echo through the centuries. Copernicus's courage and vision continue to inspire all who seek to understand the universe. Today, Copernicus is honored as one of the great pioneers of science. Statues, observatories, and even a crater on the moon bear his name. His willingness to challenge accepted wisdom and search for the truth remains a model for scientists everywhere. The story of Copernicus reminds us that great change often begins with a single, bold idea. Thanks to Copernicus, we now know that the Sun is not just the center of our solar system but one of countless stars in a vast universe. Our understanding of the cosmos continues to evolve, but the heliocentric theory remains a cornerstone of modern astronomy. The journey from Earth-centered to Sun-centered thinking opened the door to endless discovery. The story of Copernicus and the heliocentric theory continues to inspire students, scientists, and dreamers around the world. By showing the power of curiosity, evidence, and courage, Copernicus's legacy encourages us all to keep asking questions and seeking new answers. The adventure of discovery is never-ending. Heliocentric theory opened our eyes to a universe full of possibilities. By daring to look beyond the familiar, Copernicus helped humanity take its first steps into a much larger world. Today, we continue to explore, discover, and imagine what lies beyond. The legacy of Copernicus reminds us that the universe is vast, mysterious, and waiting to be understood.